Hello, all three people that are watching the stream right now. Welcome to our robot in 3 days. Well, we obviously started a week late. The idea is that we can see what other teams have done and take their ideas and improve upon them for our robot in 3 days, and see what actually does work and what doesn't. So first, we got a bunch of stuff. We met earlier in the week, and we came up with a bunch of stuff that we want to try to work on during robot in 3 days here. So we've got, to start with, we've got the first two items, which is just build field, which we got going on over here. We just got our field kit, and we've opened it up and we started assembling it. We also have live stream. Obviously, we're doing that. And then we have a bunch of robot-specific stuff, which we've divided up into 6 categories. Yeah, 6 categories. So first, we have chassis. We're going to start with testing a holonomic chassis this year. Most of the time, we use mechanism chassis. But we're thinking this year, since you're basically driving in an L, it would probably be beneficial to be able to drive just as fast in every direction, whereas mechanism strafing is significantly slower. So we're going to start with the holonomic chassis and then move on to mechanism after we finish the holonomic. Then we're working on adapting our center grabber, which we had last year, to pick up pixels and specifically be able to pick up and drop off 2 pixels at the same time. We also have making an active intake, which hopefully will just be able to speed up our pickup a lot, because we've figured out this year doing some basic math that we'd need to have about a 7-second cycle if we wanted to be able to empty out the wing with one robot. So we'd figured, and it takes about 7 seconds for our current robots to just drive that distance. So we're working on a lot of different ways to make like picking up and dropping off as fast as possible. So we're working on an active intake, hopefully. Then we have for picking up the robot. I'm going to be working on that. We have a bunch of different ideas, like just arms and using worm drives and stuff like that. The first thing we're going to work on is something we saw on Fun's Robot in 30 Hours videos, is the flexible hook winch, which pretty much the idea for that is that we're going to have a like flexible flexible rod with like a hook on top, and the idea is that we're going to be able to hook that hook onto the bar using that flexible but still stiff enough to hold the hook. And then we're going to have a string attached to the hook, so that way we can pull down on this string, and so that way, and the part that held the hook is just going to be able to bend and move out of the way, and the string will be able to pull the robot up. And then for airplane launching, we're going to start with the rubber band launching system, and then move on to counter-rotating wheels and try to figure out which one's more consistent. And then for programming, we're working on field-centric, because again, we're kind of driving in like an L shape this year. So hopefully we can make it field-centric so that driving feels a little bit more fluid than what it would feel like with robot-centric. Alrighty. So first stop is our field-centric / just general robot coding spot. You guys have anything to say about field-centric or overall code?
Right now we're working on the tape measure because it's simpler.
So,
Right now we're working on the tape measure because it's simpler, but the field-centric, we can't put it into block right now, so we are trying to find a way to use normal Java code for it.
Anything else? Is that all you got?
that's really all so far.
Alrighty. Hopefully these two are new programmers, so because none of our more experienced programmers are able to make it today. Hopefully, we believe they can make it later in the week, though, later this weekend. So hopefully we can get a little bit more done with programming whenever they get here. All right, now moving on to the building section. We've got the active intake. You want to share anything about that?
Sure. So this is one version of our intake that we're thinking about doing. It's called a rotary intake, and right now I'm just trying to build the structure but I'll be experimenting with different wheels. There's these, and then we have some Andy Mark wheels. We have some Gecko wheels that we modified, and then we also have smaller versions of these wheels.
Here's one of the modified Gecko wheels. You can see we cut like the spot. You can see that we cut what the bit that goes in between them, so it's more flexible.
Yep, so that's what I'm doing right now.
Alrighty, nice. All right, and then on to, we got the plane launching mechanism over here.
So I'm still working on the rail design that uses the rubber band. I was working with the go builder pattern, but I couldn't get it to be spaced close enough so that where did it go? This piece right here would slide easily along the rails. Then the plan is we're going to put a paper airplane inside the rails and have it be pushed by this piece here. So just gotta push it and launch it. Hopefully better than that.
Yeah, ideally.
Hopefully.
But not too far.
Yeah, not too far. Just
Alrighty, and then moving on, you can see we're working on building the backdrops here. We got the white lines on them already. And then we also have someone doing a little bit of CAD. Z, got anything to talk about? We're redoing it because we forgot to record the last one.
Okay, so I'm working on our center grabber, which the center grabber that we're planning on doing currently is going to go inside of the hexagon in the middle of this, and then it's going to have a hexagon-shaped piece that gets pushed out. It's like flexible, then it gets pushed out by a shape inside of it, a cam that spins, turns, and expands inside of it to grab it. We did something very similar last year, so we wanted to try and do it for the pixels.
Yep, and you're working on potentially making it so that it can pick up two at the same time, right?
Yeah.
Yeah, so you're working on making it so you can pick up two at the same time, right?
Yes.
There we go. Much better. So that's all we've got for right now. Obviously, we need to get some more work done, but I'll be back later.
So I have been working on our plane launcher for this season. So what I have is two L beams next to each other with a 3mm spacer in the middle to give a gap. So I can put this piece in the middle, which slides back and forth, which when powered by a rubber band will launch the paper airplane like this, forward, hopefully past the wall, but not too far. Huh? Oh. There you go. Okay. So, yeah. Currently, some of the problems it has is the rail is not secured. So when it fires, it just falls off and goes wherever it wants. Same with the rubber bands, they aren't secured. There's another paper airplane we have. The plane. Worse, significantly worse.
There we go. That's better.
So this is one of our team members here that has been working on our center grabber for picking up the pixels. If you want to go ahead and explain what you've kind of been doing.
Yeah. So we have last season power play, we had a center grabber that went and picked up the cones from the inside, and the inner size of the cones and the pixels are very, very similar. So we learned that the power play one can pick up the pixels, so we just remove the nose cone that we used for alignment and just put on screws with washers, and that way it can pick up from the floor. and then we tested it, and it works. How it works is that this one, it's a circle, and then it's just a circle, and then inside of it is the cam. It might be hard to see because it's a pretty clear filament, but it spins, and then it pushes the green piece out, and then it just pushes it into the side walls of the pixel.
What edits have you been doing to this to make it better for the season?
They are like about the same size, but changing the piece that expands out to a hexagon that's a bit bigger, I think, and making it so that it can pick up 2 elements at once, and then drop them off at separate times.
Okay. Well,
Alright, so we're about to print laser cut the holonomic chassis board. So this is going to be the base for the chassis. We'll then mount the motors and put on the wheels.
Do we have anything else that needs printed right now?
Cut that out a bit.
All right, so what's going on, Clayton?
Well, it didn't cut all the way through, so now we get to cut it out with an X-Acto knife.
Yeah, that's quite. That did not cut anywhere near all the way through. Well, we could cut it with an X-Acto knife. We could put it back in. Did you have it all the way back into the corner?
Yeah.
Why don't we do that again? And we'll just cut it again, and it'll cut all the way through. So we either didn't have it focused all the way, or the lens might need to be cleaned. So let's just run it again.
Alrighty, so update for the hanging system. I have the the hook that we're going to use. I have that cut out, so ideally it can come up here and wrap onto the pole, and then we'll be able to pull it straight down, and since it's kind of like over center, it'll just pull right there instead of like pulling and then just pulling it off. So yeah, that's the plan. Here's I got the flexible bit too here for, so we're ideally going to be able to just zip tie this on here, and then we'll be able to, I also got a hole for the string, so we can just put the string in the middle there and pull down. Hopefully it works. Alright,
Alright,
so
I'll start.
we're going to quickly talk about what we've gotten done today, and what we're going to try to get done tomorrow, probably. I don't know.
Yeah, so I finished the holonomic chassis, so this should be ready to test as soon as the programmers can upload some code to it.
And why?
And
Oh, sorry. I thought you were done.
yeah, and tomorrow I'm gonna be working on a claw to pick up the pixels.
And why are we working on the holonomic chassis?
We're working on the holonomic chassis because it should be faster than the Go Build a Strafer chassis.
It should be faster because it doesn't lose speed on
Faster 'cause
like horizontals.
Yeah, because whenever you're strafing with
Yeah,
a
strafing.
mechanism chassis, it's slower than just driving forward. Whereas holonomic doesn't have that issue.
Yep.
Alright, you want to go next?
Yep. So I have been working on our paper airplane launcher. So I got just a string, a rubber band with a piece on a rail, just slides forward, and hopefully it launches an airplane. But I've been having problems with reliability in launching it.
Yeah, it seems like probably the #1 issue.
Yeah.
Alright, you want to go next, Logan? Or you want to?
I don't.
Alright, let's let Elizabeth go.
So I finished both of the backdrops, and then I've started on the stage door.
Alright, let me see if I can fan the camera so that we can see the backdrops. That was not smooth. But there's one backdrop, And there's the other backdrop. Yeah, 2 backdrops.
You almost hit me with that. Yeah,
There we go.
that was going.
Okay, why don't you go, Logan?
Could not cause damage.
All right, so I did some more work on this, which we now call the finger smasher, because my thumb and Preston's finger both got caught in it. We might need to think about some safety options, but that doesn't matter right now.
We don't got time.
We don't got time for safety third.
Oh,
But apart from that, it works okay. I might need to make it a little bit wider so we can actually pull pixels in, because the pixels are wider than the space between the channels, so we can't really tell if it'll pull the pixels up the ramp or anything. So that's what I got done.
So what I worked on doing is we have the tape measure attachment, obviously. We've had this for a while. What I've done today is I've taped some cardboard to it. So theoretically, the idea with this is that we will be able to extend out the cardboard, right? And then like drop it onto some pixels and then pull it back in. And hopefully that'd be a lot faster than actually just driving to the pixels instead.
This is the reverse snowplow tape measure.
Yeah, that's what we're calling it.
The RSPTM.
Or snowplow. Yeah, that's right, that's right.
RSPTM?
Yep. So
Sounds
yeah.
like a disease.
Anyway, so yeah, hopefully this will be faster than driving, because we've learned that we're gonna have to be very quick. Have about like a 7-second cycle time if you want to empty out the wing with one robot.
And that's per 2 pixels.
Yeah, and that'd be picking up and dropping off 2 pixels in 7 seconds. So, and driving, no, not driving back, never mind. But, so yeah, we're obviously focusing on speed a lot. Hopefully this helps with speed. The programmers have been working on getting this programmed. Hopefully I think they're really close, so they should be able to get it done tomorrow.
That is the.
Alrighty, and the last thing we did, there, is we worked on this. I designed this hook to be able to hook onto the thing that you need to hang off of. And so the idea with this is that we have this flexible piece. This is just some filament. But the idea is that we'll be able to have this hook like up with the flexible bit. And we'll be able to hook it on. And then there's a hole in here. So we're going to attach a string to the hole. And then we're going to have a winch that pulls down on the string. And this part just flexes. So that way we don't have to design like a complex arm to like pull up the robot and everything. And you just need to have a winch. So hopefully that is a lot simpler and more compact than an actual like arm and everything. And I think that's all we've gotten done today. I think the programmers also made some progress on field-centric driving instead of robot-centric. So that should also be helpful for speed. Do you guys have anything else to say?
Nope.
All right, one of you come roast the program.
Remember, safety is important. Don't be like this guy.
He's not on screen.
He's,
Don't be like this guy.
don't be like him.
He's not a good
Do not be like him.
Show your hand. Boom. Yeah, that's why you don't want to be like him.
Yeah, just
He-
don't.
this
Just
man is
think
not
before
OSHA
you do things. Yes, I did not think before I did things.
That's why he is not OSHA approved, okay?
All right, now we have a video to make. Bye. Someone end the stream.
End the stream, quickly. Come on.
stream.
Come on.
Just hit the stop streaming button.
I think so.
Okay, 3, 2, 1.
Does hitting the stop streaming button actually stop the stream?
Yes.
Okay.
Okay.